Performance time, come on and grab your friends. We're going to find a memory leak. I've got no friends but virtual users, so tests never end. It's performance time.
Hello there. This will be a pretty quick video where I wanted to explain how important it is that if you performance test an environment with stubs in it, that those stubs need delays, right? So let's first of all talk about the real world. So we have an example here where we're looking at like a flow over time. We'll have a client and it will make some kind of request and there'll be a little bit of network time. Then there will be some time spent, say, in an API to do some processing. That API will then need to go downstream and call another system to do the actual processing, the service time. And that's usually where most of the time is spent. Once that's completed, then it will come back to the API to do a little bit more processing of some kind or handling. And then it's a little bit more network time to get the response back to the user or the client. So that's kind of what happens in the real world. What happens if we have 3 of these requests come in within a short period of time? So this has a completely different impact on the performance of our API because we now have 3 network connections open at the same time, definitely. We may also, depending on the architecture, have 3 threads running in parallel, and each of those has a memory footprint, right? If we don't have a threaded model, we will at least have a queue now, a queue with 3 in-flight requests which need to be processed or are being processed right now. And that has a memory footprint as well. So the more requests there are happening concurrently, the more resources we need in our application or our API to process or to maintain that. So let's say this downstream service, we want to stub it out. We want to mock it out. Maybe we only want to focus on our API performance, or that downstream service is too difficult to test for whatever reason. So we go ahead and we set it up, and so now we just have a stub and we don't configure any delay. So what do we see now? We're still making 3 requests in exactly the same time frame, but because there's no service time, the overall time is much shorter, and we no longer have any concurrency. So we're applying the same load, but we only have 1 thread on the go at any given point of time. We only have 1 network connection open at a time. If it wasn't a threaded model, we'd only have a queue of 1 request in flight at any given point of time. So if we test this way, there is a strong possibility we're going to miss issues relating to concurrency, the length of queues, the number of concurrent threads, the number of concurrent connections open, right? So how do we get around this if we're using stubbed environments? Well, we add back in a delay to our stubs or our mocks. Ideally, that delay matches the actual service time, but if not, set something aggressive. Put in a 10 or a 30-second delay maybe. If you can run a load test at peak load and there are no issues with that kind of delay, you've got pretty high confidence that everything's going to be okay in the real world. So that's all I wanted to cover today, and I hope that makes sense. And remember, if you're performance testing an environment with stubs, make sure those stubs have service delays added to them.